Welcome to the DIY Honda Garage channel. The DTC P0976 indicates a problem with the shift solenoid valve B circuit, specifically a low circuit condition. This Diagnostic Trouble Code, DTC, is specific to continuously variable transmission, CVT systems, used in the Honda Fit from 2015 to 2020. Shift solenoids are responsible for controlling fluid flow within the transmission to manage gear shifts. The solenoid valve B directly connects to the powertrain control module, PCM, located under the dashboard, and is integral to the transmission's operation. It operates based on electrical signals routed through the vehicle's wiring harness. Therefore, troubleshooting this DTC focuses heavily on electrical diagnostics rather than mechanical issues. The DTC P0976 pertains specifically to the shift solenoid valve B circuit. The shift solenoid is responsible for regulating the flow of transmission fluid to ensure smooth gear transitions within the automatic transmission of the Honda Fit. Its position is typically within the valve body assembly, which is located inside the transmission. The PCM monitors this solenoid to determine its operational status and to make necessary adjustments based on various driving conditions. This electrical circuit issue cannot stem from any mechanical problem, like a faulty valve body assembly or degraded fluids, emphasizing that the root cause is firmly situated within the wiring and connections of the solenoid circuit. The PCM will flag this error when it detects that the voltage or resistance in the solenoid circuit falls outside of expected parameters. Several possible causes for the DTC P0976 include an electrical circuit failure that could stem from damaged wiring or connections, an open circuit where electrical continuity is interrupted, or a short circuit which leads to unintended grounding. Each of these scenarios can result in the PCM interpreting a low voltage condition at the shift solenoid valve B. Additionally, a faulty shift solenoid itself can contribute to the issue if it fails to operate as intended. Regular inspections of the wiring harness and connectors are crucial, as even minor corrosion or frayed wires can trigger this DTC, indicating the importance of good electrical integrity within the system. When dealing with a DTC P0976, drivers may notice several symptoms. Most commonly, transmission slipping can occur, where the car unexpectedly shifts gears or experiences a loss of power during acceleration. Delayed shifting could also manifest, which means that there's a noticeable lag when the vehicle is expected to change gears. This can affect overall driving comfort and lead to safety concerns when merging or navigating busy roadways. Furthermore, a warning light on the dashboard will typically illuminate, alerting the driver to the specific issue that requires troubleshooting. Each of these symptoms underlines the problems posed by an ineffective shift solenoid valve B, which is critical for maintaining smooth transmission functionality. The first steps in troubleshooting DTC P0976 involve basic verification of the problem. First, put the vehicle into the on mode, which activates the vehicle's electrical systems without starting the engine. Once in this mode, use the Honda Diagnostic System, HDS, to clear any stored DTCs, including P0976, from the PCM's memory. After clearing, start the engine and allow it to reach normal operating temperature, indicated by the radiator fan cycling on twice. This step ensures that all components are operating within the designated temperature range. Following this, test drive the vehicle in D position at a speed of approximately 37 miles per hour for about 10 seconds to confirm whether the DTC reappears. Checking for pending or confirmed DTCs after this test drive will inform you if the problem persists, providing critical data for the next steps. In the second step, you'll perform an inspection of the IG1 missole line. Start by turning the vehicle to off mode to ensure safety while handling electrical components. Utilize the HDS to jump the short circuit SCS line and wait for more than 1 minute. This allows the system to reset. Once the reset is complete, disconnect PCM connector A, which is identified by its 51P pin configuration. Then, turn the vehicle to on mode again to activate the electrical systems. At this point, measure the voltage between the two specified test points to ensure that there is battery voltage present. Test point 1 is PCM connector A, pin 11, and test point 2 is body ground. If battery voltage is present, the IG1 mis-sole wire is considered intact. If not, further inspect the fuse and wire continuity as outlined in the subsequent troubleshooting steps. The third troubleshooting step is to directly determine the operational status of the shift solenoid valve B. Begin this step by performing a dedicated test on the valve itself. If the solenoid performs correctly during testing, it confirms that the component is not at fault and you can move on to the next set of tests. If the solenoid is found to be defective, proceed to step 5 for further actions. This step is crucial as it helps narrow down the issue to either an electrical fault in the wiring or the valve performance, guiding further diagnostics efficiently. Understanding that a functioning solenoid will not flag DTC P0976 encourages strategic troubleshooting to isolate wiring or PCM problems instead. In this fourth step, you will be checking the integrity of the Sol B wire for any short circuits or disruptions. Turn the vehicle to off mode first, and again, jump the SCS line using the HDS, waiting for over 1 minute. With the vehicle off, disconnect PCM connector C, 51P, and the solenoid wire harness 8P connector located on the engine side. This allows a clear pathway for measuring continuity. By testing between the designated points, you will determine whether continuity exists between the solenoid connector and the body ground. Positive continuity indicates a short issue in the wire itself. Should this occur, repairs can be conducted by following the wire path back to the PCM and addressing any sections that may be compromised. If continuity is not present, it suggests that the wire is intact, pointing towards a possible PCM issue in the next steps of the troubleshooting process. The final troubleshooting step focuses specifically on the shift solenoid valve B's operational integrity. Start by carefully removing the valve body assembly from the transmission, which contains the solenoids that manage gear transitions. After detaching the solenoid valve B 2P connector, you will need to measure the resistance between the two specified pins within this connector. The expected resistance should be within the range of 8.9 to 12.2 ohms. If the resistance reading falls within this range, the solenoid is deemed functional, indicating that the issue lies in the wiring harness. In such a case, replacing the solenoid wire harness is the necessary course of action. Conversely, if the resistance is outside this range, the shift solenoid valve B is faulty, and the appropriate action is to replace the valve body assembly. Ensuring proper operation of the valve is critical for optimal transmission performance. Final repair verification is a crucial phase in the troubleshooting and repair of DTC P0976. Start by using the HDS to recheck the vehicle for any DTCs once repairs have been completed. It is essential to ensure that no residual codes remain, which could indicate unresolved issues. Following this, confirm the proper operation of the transmission by monitoring its functionality at various speeds and conditions, ensuring no slip or delayed shifting occurs. A thorough test drive replicating normal driving scenarios often sets the best context for final verification. If the transmission shifts smoothly and operates without triggering DTC P0976 again, it suggests successful repairs and restoration of the system's integrity. Preventive maintenance plays a vital role in avoiding future issues concerning the shift solenoid valve B and related electrical systems. Regular electrical inspections should be conducted to identify any visible wear and tear, including frayed wires, corroded connectors, or any signs of moisture intrusion in connectors that could lead to shorts. It is also essential to check the overall condition of the wiring harness frequently, ensuring that it remains secure and free from damage. Additionally, an adequate level and quality of transmission fluid must be maintained, as fluid condition can impact solenoid functionality and lifespan. Engaging in these preventive practices enhances the longevity and reliability of the transmission system, reducing the chances of encountering the same DTC in the future. In conclusion, the DTC P0976 signals significant electrical issues primarily within the shift solenoid valve B circuit. The diagnostic process highlights the necessity for thorough inspection of wiring and connections, while also emphasizing the importance of ruling out mechanical faults in the transmission. Key symptoms include slipping or delayed shifting, making it essential for prompt troubleshooting. The outlined methods provide a clear pathway for diagnosing, verifying repairs, and ultimately ensuring the proper functionality of the transmission. Finally, maintaining a strict preventive maintenance regimen can serve as an effective means to reduce the likelihood of encountering this issue repeatedly, effectively enhancing the performance and reliability of the Honda Fit. Please like and subscribe to the channel. See you next time!